Hey everyone, so in this video we are going to discuss this question. So it says that in circuit shows that figure 3 in the EMF of cell EMF is 2 volt and its internal resistance is negligible. The wire AB is 100 centimeter with a resistance of 4 ohm, and then the EMF of the cell is EMF of cell X down here is 1.5 volt with internal resistance of 0.6 ohm. And then the question E is asking for when the galvanometer reading is 0, what is the length of LAP? So basically, I've written here that purple color is the upper circuit and the blue color here is the lower circuit. So, and then there's a bridge here connecting the two circuit together. So the purple circuit again is the upper circuit and the blue color is the lower circuit. So we can see here, we just write the VRL table. VRL, this is for the upper circuit, and this one is for the lower circuit. I like to put it in blue because I've already draw the color blue lower circuit. Right, so we go for the upper circuit first. So the upper circuit, we don't have any other resistor, means that whatever that the EMF have here, that is our VAB. So this is our EMF. And then we have here this blue color is not a complete circuit. There is no current passing through this blue circuit because it is not complete as a whole like this. For example, it is not a complete circuit. It's just hanging there, just one straight line, one straight wire. So we just take the potential difference as the EMF X itself. The R for the upper circuit is the RAB, while the lower circuit we don't have any other except for the internal resistance, so we just put dash there because the internal resistance cannot be put in the VRL table. Then we have L is the LAB for the upper circuit, and then for the lower circuit we have LAP. So that's our VRL table. Now let's do the calculation. So we have EMF. So I just take this one and this one. I take the V and the L since the R is, we have insufficient information about it. So EMF over EMF X, LAB over LAP. So LAP equals to EMF X, bring up here, is 1.5. LAB is 100 centimeter divided by the EMF of the upper circuit, which is in the purple color, and that is 2 volt. And the final answer is 75 centimeter. This is for question A. Let's go to question B. Now the question B is asking you for if a resistor of resistance 1 ohm is connected in series with cell EMF, what is the new balance length AP? So I'm going to put the next slide over here. We have to draw it again. Oh, you know what? Might as well I just copy this down. Just copy this circuit. Okay, so we have our circuit again, but this time at here we have to add in another resistor, and that is R1, which with the resistance of 1 ohm. There. Now we can see that the upper circuit here we have two resistors. Two resistors? Yes. The first one is a RAB, and the second one is the R1 over here. So when we want to write down our VRL, VRL's table. So we have to, this is V, R, and L for the upper circuit, and then the lower circuit. The VRL, the V this time, we take VAB. Why is it so? Because we have to remember that V1 over here, this is a V1. The V1 over here plus VAB from here to here is equal to here. EMF equals to V1 plus VAB. Because of R1 and RAB over here, R1 and RAB over here, they are arranged in series. So means that V1 plus VAB equals to the EMF. And then we are trying to compare the LAB, which is 100 centimeter, with the LAP later on. So it is best for us to write down the VAB instead of the whole EMF, right? And then the R is the RAB, and then the L is the LAB. There you go. You can see the difference between the first circuit in question A and this circuit in question B, and how it affects our VAB value. And then the lower circuit, we don't have any different with it. So we just, again, this is incomplete circuit, so we just leave it like that. So this is a EMF X. So whatever potential difference we have from point here to point here is equivalent to from point here to point here. Because we don't have, for the lower circuit or for the blue circuit, we don't have current. We don't have any complete circuit passing through it. So we just write here EMF X. This one we still don't have any external resistance, and the L is the LAP equivalent. Okay, so we have to find the VAB first. So I'm going to change it back to the purple color to indicate that this next calculation is actually for the upper circuit. So we have EMF equals to V1 plus VAB. Again, so we use, to find the VAB, we use potential divider equation. So RAB over R1 plus RAB times EMF. If you look at your buku tutorial, you can see at the back of your buku, you can see that there are plenty of equation, and one of them is this one. This is a potential divider. Potential divider equation. And for our EMF is 2. And the final answer for the VAB is 1.6 volt. Once we got the 1.6 volt, and then we can continue selecting from the VRL table the V and also the L. So from here, we can get the VAB over EMF X equals to LAB over LAP. So the LAP equals to EMF X is 1.5, LAB is still 100, and then this VAB is the new voltage that we found, calculated just now. So the final answer should be 93.75 centimeter. Alright, so let's go to question number 3. So for question number 3, for question C, the question this time is changing the upper the resistor at the upper circuit, and we have to change it to the lower circuit. This time the R1 is shifted to the lower part here. So the R1, which is 1 ohm, is put here. Now in here we can see that again for the lower circuit it is still an incomplete circuit. There's no current passing through it because they are not connected from one point to another. This is just a loose end over here. So means that we can just use the basic equation from A. So we can just use EMF equals to EMF naught, because at point here is equivalent to point here. Okay, so we just use that LAB over LAP, and then we can finally get the answer, which is the same, 1.5 times 100 over 2. That's the answer is 75 centimeter. And then you might want to ask me, Cikgu, kalau lah macam gini, kalau kita letak 1000 ohm pun next to the EMF or the battery, it doesn't give any difference at all lah to the terminal voltage. Yes, apparently that's how it works. Kalau misalnya kata kita letaklah berapa banyak ohm kat sini pun, tapi dia bukanlah complete circuit as a whole circuit macam ni, then kita masih juga consider bahawa voltage potential difference from point here to point here is the same as from point here to point here, because there is no current passing through it. So kita tak ada potential difference of the whole circuit. Yang kita cuma ada ialah potential difference of the terminal voltage. Okay, so next and the last one, which is D. Okay, this is another circuit for D. Alright, let's zoom in. Now this time the question is asking for if the 1 ohm resistor is put, so I'm gonna have to erase this information because I have to put the resistor, the R1 resistor, down here. Now look at the difference it made. Now this is one EMF X again, right, which is 1.5 volt and with the internal resistance of 0.6 ohm. This one is R1, which is 1 ohm just now, that we change it to the lower circuit. Now, look what happened to the lower circuit, the blue circuit. It has complete circuit, means that there is current passing through it. Amazing thing about this one. There is current passing through it, finally. Okay. So what we have to do here, we can see that there is a current passing through this part. So we can see that we have to find the current first. So EMF X equals to current for the lower circuit times R1 plus internal resistance. Because although it looks like a parallel, it actually connected in series. The R1 and the internal resistance is are connected in series. So EMF is 1.5 equals to ILC times R1 is 1 and internal resistance is 0.6. So you can get your I for the lower circuit as 0.9375 ampere. And then from there, we can find the VAP. VAP is actually for the V of the lower circuit. V of the lower circuit equals to I for the whole current that passing through the lower circuit, ILC. So the external resistance is only R1, so 0.9375 times 1. So we can get 0.9375 volt. Okay. Now that we have this one, and then when we compare it with the VRL table for the upper circuit and the lower circuit, let's see. Now we don't have any extra external resistors put in the upper circuit, so we can just take the EMF. And then for the lower circuit, this time is the V of the lower circuit. Resistance for the upper circuit is again RAB. And then for the lower circuit, we have R1. This time we have R1. L is the same, LAB, and then the lower part is LAP. But since the question is asking for the LAP over here, so I'm just going to take this one and then I'm going to compare it again with this part. Okay? So EMF over VL equals to LAB over LAP. So LAP equals to 0.9375 volt times 100 centimeter divided by 2 volt. So our final answer is 46.88 centimeter. Alright. Thank you everyone. Bye-bye.